Okay, quick little mic check here, and we're in business. Mic appears to be working. So, we are, as I say, in business. So, welcome back for more Atari 5200 programming. We're going to be continuing our little Tetris experiment here, which I currently have running. And last time I did this, which I think was 2 weeks ago, we got the pieces moving, and we got full collision detection. I can move the pieces left and right, and they collide as appropriate and fall like they should, and new pieces come in. And that was about where I left off. So there are 3 things I would like to get done today, and I think that might be where I stop. Not just this project, probably this series as a whole. So I think there's really not much else I can really think of to do. But the 3 things I would like to get done, just to flesh this Tetris game a little bit, are piece rotation, fast dropping, and then line detection and adjusting the board after the lines go away. So those are the 3 things I would like to do today. And I have a very solid plan for the first 2. The last one is a bit tougher, and is, in my experience, since I've written Tetris many times, in my experience, the whole line detection and removal part is really the hardest part to get right, especially on a console like this where you're down, really low level working in assembly. So I've put a little bit of thought into it, but not a whole lot. So I'll be kind of winging it on that. But I'm very excited to get to that to see what I come up with, because I'm not even sure what it's going to be yet. So it's exciting for everybody involved. But I think I want to start with fast drop, because that's going to be the simplest of those 3 items to do. So I'm going to do in the order of fast drop, rotate, and then line clearing. And it's also useful to do line clearing last, because it's kind of difficult to set up lines to clear if I don't have rotate. So, and less so if I don't have fast drop. Rotate's more important. But anyway, so let's go ahead and get started here. So we have the code here. And I already know how I'm going to implement fast drop, at least in theory, so we're just going to go ahead and try it and see if it works out. So the first thing we're going to need is a modified drop timer. So right now we see up here we have a drop timer length of 60, which means the piece drops once every second. Now that's pretty slow, but for testing purposes, that's just fine. Now, as I mentioned, I think I mentioned in a previous video that there are 2 approaches to fast drop that different Tetris games use. Approach number 1 is a sort of instant fast drop, where as soon as you hit whatever is keyed to fast drop, the piece is down. Just instantaneous, and then your next piece comes in. The second method is to use a method you have more control over, where activating fast drop just causes the piece to drop faster, but you can let go of fast drop and then continue to manipulate the piece afterward. And that's the route that we're going to go in this project. We're going to take the more detailed fast drop, where you can actually stop it partway down. And one of the reasons I'm doing that is really because of the 5200 controller and its analog nature. With a digital control, the fast drop can be pretty useful, but I feel like with the analog 5200 stick, having fast drop might be difficult. So I want to make it more controllable. So in order to do that, we're going to need a second drop timer length that's going to be the fast drop time. So we're going to switch this to fast drop timer length. So the current drop time is once per second. We'll try some different values here. Let's just start with 10. We'll use that as a nice value. I like to line these up within each block. That's just a me thing. So we'll start with 10. I think that's probably too slow, but it's something to start with, and we can just play with it from there. So how do we do fast drop? Well, there's definitely a right way and a wrong way to do this. And the way we're going to do it is actually rather simple. So here we go. Here's where we actually test the drop timer, right here in this code right here. Say we load the drop timer length. Oh no, sorry, this is... Oh yeah, I am in the right area. So right here we decrement the drop timer. If it's not equal to 0, then we skip over this code, these 3 lines. And these 3 lines reset the drop timer. Actually, no, we skip way down somewhere else. These 2 lines reset the drop timer, and then go into the actual... Actually, no, these 2 lines... Sorry, it's been a while since I've looked at this code. These 2 lines reset the drop timer, and then from here, we start the actual act of dropping the piece. So what we're going to do, we'll just do it right out of the gate. There's a lot of places we could put this code. I'm just going to put it right up front. We'll see how this works. So I'm going to use down on the joystick as the drop timer trigger. So we're going to have to load pot 1. So pot 1 is the vertical axis on controller 1. And we're going to need to compare it to some value. Now, I want to go see what I'm doing for left and right, because I honestly don't remember. Build screen, generate new piece, validate piece, update current piece. Where do I even do this at? Wait for view. Okay. Here we go. Okay, so I use 70 and 150 right now. So I usually use 110 as a middle value for the controller axis. So right now I'm doing plus or minus 40 by the look of it. So we'll stick with that for now. So down is in the plus direction. So we'll go with 110. So if the stick isn't down past 110, then the user is not doing a fast drop. So in that case, we're just going to hop right over this next part. So we'll put a BCC in here to no fast drop. And that'll be right here. No fast drop. Now, if we're in here, then the user is holding down. So now we need to activate the fast drop. And the way we're going to do this is we're going to load the drop timer. Now, what we're going to do is we're going to compare it to that fast drop time that we just set up. And I've already forgotten what I called that. Fast drop timer length. So we're going to compare the current timer to the fast drop timer length. Now, if the timer is already less than or equal, I think we're going to do strictly less than, but it won't matter. But if it's already within the fast drop range, then there's really nothing for us to do. I mean, it's already dropping fast. So we're going to branch on carry clear to no fast drop because we don't have anything to do. It's already within that fast drop range. But if we're in this code here, then it means the timer is currently greater than, or possibly equal, it's not going to matter, greater than or equal to that fast drop length. So if the stick is down at this point, we want to change the timer. We're going to set it to the fast drop. So we'll load fast drop timer length, actually, and write it to drop timer. Although, you know what? I think there's a faster way. You know, here's a, okay, this is just a micro optimization here. So you notice, okay, we load the drop timer compared to the length, and then we load the length. So let's do this the other way around. We'll load the timer length and compare it to the drop timer. I'll have to reverse the jump instruction. So if the timer length is greater than the drop timer, we do nothing because the timer's below it. Otherwise, we just write to see. I got rid of one of those loads because we'll put the thing we might write into the accumulator. That way we can just write it directly if we need to. So I'm just saving a couple bytes and a few instructions there. But this might be all we need. This might do it. Yeah, do it again. I do that all the time. So let's see what happens here. So, whoa, okay. That is, okay, well, something's wrong because it's dropping fast, like, all the time. So I have clearly done something wrong here. So let's take a look. Did I get this comparison backwards? Load pot 1, compare it to 110. If it's less than 110, we go to no fast drop and just do the normal stuff. Otherwise, compare fast drop timer length. I didn't get this comparison backwards, did I? Pot 1 is the vertical pot, right? Yeah, pot 0 is okay. I'm not sure what I did wrong here. But hey, that makes for fun debugging, and learning how to debug these things is a very valuable skill. Let's look at it one more time. So, oh, whoa. Okay, I think the value... Oh, I compared it to 110. That's my middle value. Yeah, I was supposed to go plus or minus 40. Yeah, the value's too low. Whoops. So 150 should be what I compare it to. Okay, so now it's dropping normal. Now when I push down, there it goes, dropping fast. And then I let go and it stops dropping fast. Now, look at that. That's nice. It's awfully slow, though. I think we need a faster drop timer. So let's go up to this constant here. We're doing it right now we're doing it every 10 frames. Let's go every 4 frames. Or did I put 4? Okay, I put 3. We'll try 3. We'll see how 3 works. Maybe it's good. Oh, yeah, that's better. All right, so now we have fast drop. Now, one thing I might want to do is do some sort of input buffering to stop fast drop once the piece grounds itself and require you to... Because now if I hold fast drop, it just keeps going like this. I think that in a real game, I would probably want to have to repress down when a new piece comes in. I could just ignore that and say, good enough, we got fast drop. You know, let's implement that. I'll show you one way you can implement that, because we're actually going to need to use the same technique for the rotate button, because we don't want it to just keep spinning real fast. So one way you can do this, if you want to have this sort of, I don't even know what the right word is for this. Something where you need a release before you react again. So one way you could do that is by remembering what the previous value was. So I'm going to say, so we'll call this fast drop active. And we'll store it at address 23. So what we're going to do then is the following. So now we're only going to react to the change in pot 1 if fast drop active is set to 0. So here's what we'll do then. So, okay, so we're going to load fast drop active. Wait, no, we're going to do this the other way around. So the idea of what we're going to do here is we're going to remember if we were fast dropping on the previous frame. So, you know, I got to think about this. I might be doing it wrong. Okay. So we want to start fast drop. The more I think about this, the worse it gets. Okay, here's what we're going to do instead. We're going to have a flag here. Called no fast drop. Sorry, I'm picky about my indentation. So, if no fast drop is set to 1, we don't allow fast drop. So what we're going to do here is, first thing we're going to do is we're going to check that. We're going to load. No fast drop. If it equals 0, we're allowed to fast drop. So we'll go to fast drop OK. If it equals 1, what we're going to do is we're going to reset it if the pot is in is not in the drop zone. So we'll compare that. So if it's below that, we reset the fast drop. Otherwise, we just jump to no fast drop. And you'll see how this works in a moment here. So we'll just decrement no fast drop. And then fall through into the fast drop code. So what I think this should do, there's more to this. Oh, I forgot fast drop, okay. Okay, now every time a piece gets grounded, so okay, here we go. Generate new piece. So every time a piece gets grounded, we're gonna set no fast drop to 1. No, we'll just, yeah. So if I did this right, what this should do, okay, we're going to fast drop. Okay, now it's not fast dropping at all. I screwed up somewhere. All right, let's see if we can fix this. I know what I'm trying to do, but it's really hard to put it into words here. All right, so we load fast drop. So it equals to 0. We can do fast drop. Fast drop, okay. Let me just do the fast drop, okay. Otherwise, if it doesn't equal 0, we load the pot, compare it. If it's less than that, we set it back. You know what? This needs to go there. That label's in the wrong place. That's what's wrong. Whoops. Okay, I think that'll fix it. Missed by 1 line there. All right, so there we go. We fast drop stops. Now if I hold fast drop, it stops. It doesn't go into the next line. If I let go of it and then push it, now it drops again. So that sort of input buffering technique is very useful, especially for things like, say, shooters where you don't want to be able to hold down the button and continuously fire. The little shooter project we did earlier in this series, we allowed that. We just said, you hold down the button, it's going to keep firing. I did that mostly out of simplicity. But if you want to sort of require a press and then a release, you have to remember what the last button state was and then check against that. And we're going to do that when it comes to rotation, because you don't want the rotation to just start flipping out. But this stops the fast drop once you hit the ground. So it makes it a lot easier to control. So we've done fast drop. That's it. That quick. I've been at this for, I don't know, 10 minutes, 20, 15 minutes. I don't know, but it's done. Okay. All right, so let's start talking about rotation. Now, rotation is a much more complex thing, but I have a plan. So the first thing we're going to need in order to do rotation is a set of rotation tables. Now, let's start with a piece that only has 2 rotation states. All right, so here's our pieces. So when it comes to the Tetris pieces, the square is a bit of an oddball because it doesn't have any rotation to it whatsoever. The Z and S pieces, as I call them, only have 2 rotation states. The other pieces, being the 2 L pieces, the T piece, and actually the straight piece as well, only has 2 rotation states. The 2 L pieces and the T have 3. So you have 3 pieces with 2 states, 3 pieces with 4 states, and 1 piece with just 1. Which is a nice kind of geometric thing, I guess. So what we're going to do here is create a series of tables. And we're going to have a table for each piece that tells it how to rotate. Now, I mentioned in an earlier video, there's really 2 ways you can go about this. You can do the simple way where you only have 1 rotate button. So you only rotate in 1 direction. Some Tetris implementations give you 2 rotate buttons, and you can rotate in both clockwise and counterclockwise. I don't think I'm going to do that in this video, but if you want to grab the code off of the Atari Age forums and implement it as an exercise for yourself, by all means go ahead. You could probably follow what I've done kind of in reverse, if that makes sense. If you remember how to access button 2, which is a bit tricky, but you can find it in my earlier videos and there's documentation for it. You could try to implement two-way rotation, but I'm not going to do that here just to save time. So I'm going to start, I think, with, we'll start with the straight piece since it's the last one. So I'm going to set up this series of tables. So we'll have, we'll call this straight rotation. So how do you define a rotation? So the way I'm going to do this is in offsets from the previous state, if that makes sense. So I'm going to have coordinates for all 4 blocks that make up the piece, but they're going to be offsets from the state you're rotating from. So to get the new states, you just take these offsets and add them to the existing coordinates, and you'll get the coordinates of the desired rotation. Now, this little table right up here, this is the table we put together for the pieces. And these are the starting locations of the 4 blocks. This is X, Y of block 1, X, Y of block 2, X, Y of block 3, and so on. So we're going to use the same format. It's going to be kind of in parallel, but it's going to be offset. So, for example, the straight piece here starts at 5, 0, 5, 1, 5, 2, 5, 3, just straight up and down. Now, you need to pick kind of an axis to rotate, like one piece to kind of be your rotation axis. And I'm going to pick this piece to be the second one down to be the rotation axis. And the reason I do that is because on an earlier video, we added like an imaginary left row to the board that is there just for collision purposes. And this will keep it within that border because the right row is gone forever. But on the left, we have one imaginary row, and this will fit with that row for collision checking purposes, which will work out really well. So this right here is going to be my rotation axis, this second block, which means that that's not going to change in the rotation. So these other 3 blocks, we're going to adjust our coordinates relative to the previous state. So we're going to consider this to be the starting state, which is the straight up and down state. So the first rotation for the straight piece is going to be, so you got to kind of visualize this in your head here. So if we got straight up and down, 1, 2, 3, 4, and the second piece is going to be the axis of rotation, then the topmost block is going to go left 1, up 1. Because, well, down, but that's a higher value. So the first block would go -1, 1. That'll get it to where it needs to go to rotate. Now, block 2, we said, was the axis of rotation. So that's going to be 0, 0. That's not going to change. Now, block 3 is going to go 1, is going to go right 1, up 1. Which is going to be 1, -1. Block 4 is going to go over 2, up 2. It's going to be 2, -2. So this is the rotation pattern for that block. Now for a 2-state block, the rotation in the other direction is just going to be the exact opposite to go back to the other one. So the other state is going to be 1, -1, 0, 0. So again, that's our axis of rotation right there. -1, 1, -2, 2. So this is our rotation table for the straight piece. These are the changes we need to apply to each individual block to get it where it's got to go. Now the straight piece is piece number 6. This is 0 through 6. So what I'm going to do is I'm going to hard code piece number 6. So here we were loading a random piece. No, we're going to load number 6. So this will get us straight pieces all day. However, there is still some more work to do. So we now have the rotation table, but we need to know a bunch of information here. One, we need to know which table to use to rotate the piece. We need to know where our current position is in the table, so we know which entry to use. And we also need to know what the last entry is, so we can loop back around when we go past the last entry to the beginning of the table. So there's 3 pieces of information we need in order to loop these pieces, and we're just going to stick this all in here. So the first thing we need to know is the rotate table. Now this is going to be a 16-bit value, because it's 2 bytes. So we'll call it rotate table. We'll stick that at address 24. Then we need to know, where are we in the table? That's going to be rotate index, which we'll put at 26, because remember, rotate tables, it's an address, so it's 16 bits, so it needs 2 bytes. So we got to make sure we got room. And then we need to know, what is the last entry in the table so we can loop back around. Now, there's a couple different ways you could do this. You could make, this could be like it depends on where you want to check this. I'm going to check it before we rotate. So we're going to call it rotate end. And we'll stick this at 27. So this is the information we need in order to rotate this piece. Which means we need to actually have this information and put it into those values there. So we're going to make some more tables, because data tables are your best friend. So we're going to create some tables that we can index with the piece ID to get this information. So first we need to know, where is the rotation table for this piece. It's going to have rotate table low. Okay, this is the low byte of the rotation table for each piece. I'm just, now, since we're working with piece number 6, we need to be able to index all the way down. So we need to make a full 7-entry table, even though we're going to leave the beginning parts of it blank for now. But the low byte is a way to write that. Straight rotation. And then the high byte of the table, rotate table high. Again, we need a full table because actually, you don't need the number sign here, actually. Just that's fine. This is just data. The high byte of straight rotation. Okay, so there's a table we can use to get the addresses that we need. Now, the next thing we need to know is, okay, well, the starting index is always going to be 0. That's not a problem. But we need to know, where's the end of the table? How long is this table, so we know when we need to loop back to the beginning of the table? So we're going to go rotate table length. I have another lookup table. Now this we can fill in. We know what this is going to be. So here we go. So the L piece has 4 entries. The L reverse piece has 4 entries. S piece has 2. Z piece has 2. T piece has 4. Square piece has 0. Actually, it's going to have 1. Because it has 1 state. I got to do it that way. And finally, straight piece has 2. So now we have these tables that contain the data we need to set up this rotation. So the next thing we need to do is, whenever we create a new piece, we need to fill in this data so that we can rotate it. So let's go ahead and do that. So go back here to generate, let's look for random, because that's where it was. Okay, so here's where we generate a new piece. We do all this stuff, load up the graphics. Okay. Okay, right now it calls this done, but we'll call it, actually, you know what? I should do this as soon as we get the, value, because we mess with the value here. Let's just go ahead and do this. So we need to load, well, okay. So we have the current piece ID in the accumulator. We need to put it over into Y so we can do some indexing. Then we load rotate table low, index with the piece ID, store it in rotate table. Then we load rotate table high and store that in rotate table plus 1 is the high byte. And then we load rotate table length indexed by y and write that to rotate end. And then we write 0 to rotate index because we always start at index 0. So if I did this right, oh yeah, and then we need to put the index back into the accumulator because it's used for the rest of this code to set up the piece. So we put it right back. Unknown mnemonic, night. Yeah, it's just my failing eyesight. Rotate table. I sure am glad that the assembler can catch all these typos for me. Okay, is that enough? Okay, perfect. So now we have created a rotation table. We have gotten the necessary data and set it up for this piece we're about to drop. So now we need to actually do something with it. So how do we go about doing that? Well, we're going to do a few things here. So first off, we need to have some kind of control over the button because if we don't put in something, then if we push the button, it's just going to rotate every single frame and it's going to be so fast that you can't do anything about it. So we need to have a last button state. And this is similar to what we did with the down thing. So we're going to create a new location in memory. We'll call it last trigger. Okay, now, if you remember back in my earlier video, I talked about how the trigger button, when you read its value, it's the reverse from what you might expect. If the value is 0, it means the button's being pressed. If it's 1, it means it's not. So when we start the stage, we want to start off with 1 in last trigger. Actually, no, what we can do is easier because we zero the memory at the beginning, so we know at this point it's 0. So we can just increment last trigger. Okay, so that'll get us where we want. So basically what's going to happen here is when the button is pressed, we're only going to rotate if on the last frame it was not pressed. That way, if you hold the button, it won't keep rotating until you let go of the button. So let's see where we want to do this at. We want to do it before the piece gets grounded, certainly. Ooh, you know what I just thought of? I'm going to do this now while I'm thinking of it. Okay. So we have this here. This is the lookup table for the different cells on the board. And we use this for the collision checks, which we're going to need for the rotation. So we need to have a couple extra rows on the bottom. Because without that, the rotation checks are going to go off into who knows where. Now we put one extra row on the bottom. Because that allows us to look up that bottom row when the piece is falling to see if it's possible to move there. So we need 2, because the rotation of the straight piece ends up shoving 2 squares down, which might go 2 into the bottom. So, although, you know what? Actually, I think we can get away without this. And the reason I think we can get away with this is because that's block number 4, and if it checks them in that order, block 3 would fail before block 4 even got. You know what? Let's just do it the right way. Okay, so we need one more entry here. So this is going to be 7E plus 28 hex, whatever that is. I've just opened up a calculator that you can't see. My apologies. I'll open up a calculator I can't see either. My calculator says the value we're looking for here is A6. Okay, so now we have this hypothetical extra row on the bottom of the board, which will allow us to collision test that extreme rotation case. So, oh wait, it's not 28. Yeah, it is 20. Yeah, it is. Never mind. That's right. Okay, so we need to actually do something with the trigger and make these rotations happen. And my cat has just arrived to yell at me. Okay, so let's see here. Update piece, ground loop. I'm gonna have to review some of the subroutines you wrote for this because I've forgotten a lot of this code in the last 2 weeks. I've been working on so many other things. Okay, here we go. Generate new piece. So this is where the piece has been grounded. So here, okay, so here we've done all of the drop checking. Now we're checking the move, like horizontal movement. That's fine. Move left. We test left and right moves. Move done. Okay, here's where we'll do rotate check. Put away here at the bottom. So what we need to do is this. So we're going to, okay, so we're going to load trig 0. This is the primary button on the controller for player 1. And we're going to compare it to whatever the last trigger value was. So whatever the last press was. Now, if they are equal, that means that the button hasn't changed. Which means we're not going to do anything because the button hasn't changed. So we're going to branch to rotate done. That says dobe, doesn't it? Rotate done. Now for here, then the trigger has changed. So we're going to record the new value. And then we're going to see what the new value is. So we'll compare it to 0, because 0 means the button has just been pressed. So if it doesn't equal 0, then the button was just released, and we don't do anything on release. So in that case, we'll also go to rotate done. So if we're at this point in the code, then we actually need to rotate the piece. So let's go ahead and just test this out real quick. And we're going to use my old-fashioned trick here of incrementing the background color twice, which will cause it to change. And this way we can see that this trigger suppression routine is actually working correctly. So here we go. We're going to push the button. Nothing happened. That's not the button. I'm used to a different... You know what? I don't know what the button is on this thing. I think it's actually... I don't know what the button is on this emulator. I have no idea. I thought it was one of the controller buttons. Well, that's kind of embarrassing. I need to figure out what the button is on this thing. And I've lost my mouse cursor. Is there like a configuration file for this or something? Here we go, there is. Let's search for trig. Not TIG. All right, well, it's key 305, whatever that is. I have no idea. But it's probably on the keypad somewhere here. I wish this cat would stop yelling at me. All right, well, I need to go figure out which control, and this is the button. So I'm using a different emulator now than I was using the first part of this when we were developing the space shooter. So I actually have no idea what it is. So I'm going to go find that out. Oh, okay. It's like my mic went out again. I don't know why, but for some reason, this microphone just decides to crap out from time to time. I don't know if it's the software or the hardware. I don't know. No idea. Okay, anyway, so we're going... It looks like if there's no controller input... Ah, here we go. If there's no controller input, we go back to the game loop. That's the problem. This needs to jump down to move done. There's our error. Okay, so now down here, we can... I bet if I put all this back in, it'll work fine now. We weren't even running that code. That's why it wasn't working. Okay, so now if I press that... Okay, I saw the background change, and I'm holding it, and it stops. So if I let go, press it again, it changes. So we've got our controller latch here. Now, there actually is some sort of controller, like trigger latch mode, but I've never used it. I don't entirely understand how it works. So it may be that there's a way in hardware to do this. I don't know. I'm doing it in software. Experiment. Find out. Okay, so this is where we're going to do our rotation. We've got that set up. So what we're going to do here is use those fine tables we pulled up. So now, the first thing we need to deal with... Okay, so what we're going to do is... If... we're going to use the current index. So the index we have saved is the next rotation to perform. So we're going to perform the rotation at the current index, then increment the index, see if that matches the loop point, and if it does, loop back to 0. So the first thing we need to do is to test to see if this is even a valid rotation. Now, we put together a subroutine here somewhere called validate piece. And I made sure to make this very general so that we could use it for this specific situation. So there's a region on page 0, if I remember correctly. I don't remember where I put it. Was it E0? Yeah, E0. Okay. Okay, which mirrors this. Okay. Okay, so this, unfortunately, all right, I did some goofy stuff here. In retrospect, I should have formatted this data differently, but you know what? We're going to run with it. Basically, I have to fill out this area with this data, and then we can call this to validate it. So we're going to put the proposed rotate position into that region of memory, call this to see if it's a valid rotation. If it is, then we'll do the rotation. If it's not, then we just do nothing. So let's go up here. So the unfortunate thing is that this data is laid out differently. So the data we have in the tables is loaded up like XY, 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 XY. But here it's all the X's and all the Y's. I don't know why I did it that way. I should have used one uniform data format, but that's what I did, so we're going to run with it. Now, we need to check out the pieces. So we're going to start from index 0. And we're going to... we'll call this the try-rotate loop. So we're going to load the current piece X value here. So we got current piece X, Y. So this is the X coordinate of the current piece. We got to clear the carry bit. We got to add what did I call it? Rotate table. We need to dereference rotate table with Y. So I think it's going to need some changes. This data format's screwy, but so this will apply that offset to the current X position, and then we can write it to wherever I put that data here. Where is it here? Test piece X. I can write it to test piece X, Y. So that's the first value. Now, the Y value is going to be a little trickier here, isn't it? Because this data isn't going to line up right. So, All right, I'm going to need to do something with the X register here. Can I? I don't know if I can directly access zero page with the X register. It would be extremely useful if I could. Can I do this? I can do that. Okay. Great. Very useful. Just going to... Wait a minute. What am I doing here? Okay, now we need to increment Y. This will go to the next entry in the rotate table, which is the Y coordinate. So now we load current piece Y, X. This is the Y value of the first piece. I don't think any... You know what? I'm going to clear the carry bit just in case, because I'm adding negative numbers here, and that gets weird. I don't remember exactly how that goes. Then we'll add, again... rotate table Y. Now we're going to write this to current piece Y. No, to test piece Y. X. All right, so if I did that right, this applies the desired transformation on the first piece, the first chunk of the piece, and writes it there. So now we need to increment X to get to the next piece. We'll compare it to 4. So if it's 4, then we're done. If it's not 4, then we go back. Well, actually, we need to increment Y as well. If it's not 4, we go back to the try rotate loop and continue filling in the data. Okay, I'm going to test this real quick. So I'm going to put a jump star in here, which is just... If you don't remember seeing this before, a jump star just jumps back to itself, so it effectively will lock the game. I just want to see what data we get from doing this. Okay, so I moved... Wrong button. There. Okay, so... You know what? Let me start this again, because I want to get that in a known position here. Okay, it's at the very top. So the game just locked up because I just tried to fill in that data. We're going to look at the memory. So we'll break the program. I don't remember what the command is to view memory. M for memory list. Okay. So M E0. Let's see what we got here. All right. So the first 4 are the X values. And since we're rotating now to the flat side, this looks right. 4, 5, 6, 7. Because 5 is where we started. So now we're at 4, 5, 6, 7. That's fine. Now the Y values are... 4, 2, 0, and -2. That does not look right to me at all. Not sure how we got those. The 4 is right, I think. Yeah, those don't look right to me. Let's go check out the tables. So, what do we got here? All right, so the straight piece starts at 5, 0, 5, 1, 5, 2, and 5, 3. So, 1 minus 1. Oh, I did that backwards. No, that's the second rotation. This is the only one. Okay, so -1, 1 should put the first piece at 4, 1. So we have 4, 4 right there. And this should be a 1. I don't know why that's not 1. So it should be 0 plus 1. All right, so we did something wrong. We meaning me. No meaning yes. So let's go back and look at this then. Okay, so we start with Y at 0. So this is the first entry of the table. We load the current piece X, clear the carry bit, add that to it. That's right. the X pieces, the X values all came out fine. I mean, this makes me think that maybe I'm getting the values right. I'm just writing them to the wrong place. So I load current piece Y, indexed by X, because we're on the first piece. Add the rotate table, the next value in the rotate table, because I incremented Y, so we're pointing at the next value in the table. Write it to last piece Y, or test piece Y, X. Interesting. All right, not sure what I'm doing wrong here, but let's figure it out. So I'm going to do we're going to do a debugging session, because debugging sessions are always instructional. So I'm going to look at the listing. There's an option you can pass to DASM that creates this. This tells you the address of all the instructions. I just typed listings. I had that on my mind. So I'm going to find where this takes place here, and here it is. All right, so I'm interested in this first instruction where we load the current piece, where we actually start doing this, and that's at address 41A6. So we're going to start the program, break it, and again, I don't know the commands for this emulator yet. I gotta look up the breakpoint. BPC. All right, let's go put BPC 41A6. Then I'm going to reset the emulator. It's not a valid command. What is the valid command? Okay. Here we go. Rotate. Okay, so now we just hit the breakpoint. So now we can step through and watch what happens. So right now we're at the instruction where we load the X coordinate of the first piece. And you can see the register output right here. So we load this into the accumulator. We get 5, which is correct. We clear the carry bit, add the offset to it, which is going to get us down to 4. That's correct. And then we store it to the test values. Then we go to the next entry in the table. We load the Y value, which is currently 8. We add the value out of the table. Now, this should be 9 after adding. And we get 9. That's correct. I remember the first piece was right. And then we write that to the location. Okay, that's fine. Increment X, increment Y. Compare, branch back. Okay, now this is the second piece. This is the axis of rotation. So this should not change when we do the addition. So let's see what happens here. We load a coordinate, the X coordinate. And we get 9. That doesn't seem right. Oh, I just hit the breakpoint. Okay. All right, we get 5. And we add the value from the table. We still have 5. Write it. Okay, that's fine. The X coordinate's fine. Remember, the X coordinates were all okay. It was the Y coordinates that were screwed up. Go to the next entry in the table. Okay. Load. The Y coordinate, which is 3. Okay. Now this should not change when we add this. It does not. We write it. Okay. Huh. This looks correct. I don't see what's wrong here. Okay. Let's try this again and see what we get. All right, so here we go. Rotate. So it fell down twice. I wonder if I was just reading the data wrong. No, that's still wrong. Like everything. The rotated piece should have the same Y value for everything. I don't know why we're getting those numbers. Okay, well, let's figure it out. Debugging is fun. So, all right, let's analyze this logic one more time. The funny part is that the x coordinates are fine. They're perfectly okay. I don't know why. I don't know why the y coordinates are coming out wrong. You know what I could do to simplify this? Is I can make this data match the other data. I mean, it's easier to look at like this, but it could simplify it if we just made it parallel to the way we're storing it, which is all the x values and all the y values. So what would this be then? So that first block is going to be -1, 0, then +1, +2. Then the y coordinates are going to be -1. No, it's going to be +1, 0, -1, -2. And then to get back to the old rotation would be the exact opposite. It's going to be 1, 0, -1, -2, 1, 0, 1, 2. So we'll do it this way. It's harder to read this way, but it'll work. Now, why are those not the same length? Oh, yeah, they shouldn't be. Okay, so we're going to use a table that is more accurate with respect to the way we're storing the data, which is probably what I should have done in the first place. So let's see here. How does this work then? So we're going to simplify this loop a bit. Now I think I should only need y at this point. No, I'm going to need both. So we load. No, this is actually going to be quite a bit easier. So here's how we do this now. We load current piece x, y, add rotate table I, store it at test piece x, y, because it just keeps right on going and just overflows. So this all gets very, very simple. In fact, we can make the whole thing a lot simpler by starting at index 7. And then after writing them, we just decrement if it, and then branch on plus to try rotate loop. Okay, let's see what this is just much, much simpler. We'll see what this gets us. Okay, so I hit rotate and the program is now currently frozen. So we're going to display the memory at E0. So our x coordinates are 4, 5, 6, 7, and then again 420 FE. Why are we getting that? That doesn't make any sense. We got that result last time too. Where's that coming from? FE is -2. Where am I getting -2 from? All right. Let's look at what it thinks the current coordinates are. That's address 19. Oh, whoops. Five, 3, 2, 1, 0. Oh, the pieces are the opposite direction I think they are. That's what's wrong. Okay. Well, I got this figured out now. This is what happens when you don't touch a project for a couple weeks. You forget these details. So the pieces are opposite of what I expect in the way they're listed. So we need to start from 0. in Y. We're done at 8. I think that's what's wrong. Boy, debugging's so fun. All right. Oh, I took out the freeze. We'll get this. I swear we'll get this. Okay. So now we're going to look at that memory and make sure it's correct. Okay, so now the x coordinates are 4, 5, 6, 7. That's fine. The y coordinates are 4, 2, 0, F. What the? I thought I was doing... okay. No, I didn't change anything, did I? Okay. I have to change the table. The table is backwards, is what the problem is. So we'll go back to the old formulation here. Okay. So the table is in the wrong order. That's the problem. So this needs to be reversed. Because that's just how I wrote the pieces without thinking about it. So it's going to be 2, 1, 0, minus 1, minus 2, minus 1, 0, 1. And then we negate all those values. Just go the other direction. Okay. There. Better work this time. Okay. Did I take out the... I did. Ugh, I'm such an idiot. Oh. The joys of software development. Sometimes it's just detective work for a while. You come up with the best plan in the world. It's like everything's going to work. It's going to be great. And it isn't. Okay, so now we got here. X coordinates. Whoa, wrong value. X coordinates 7, 6, 5, 4, 1, 1, 1, 1. Perfect. That's what we want. Okay, so we got that fixed. Just got to make sure we construct the tables the right way from here on out. Okay, so at this point, we have the values we want to try to rotate to. So now we call that validate function, wherever that is. Validate piece. And I don't honestly remember how that reports its results. I should have put a comment on it. Let's look at where we use it. Validate piece. Okay, if carry is set, it's not valid. Okay, so if carry is clear, we can move the piece. Okay. So now that we have all this set up, we're going to call validate piece. Now, if validate piece sets the carry bit, this is not a valid move, or not a valid rotation. So we'll just branch to rotate done. However, if it does come back and say, yeah, this is cool, we need to rotate the piece. So, how do we rotate the piece? Well, we got something for this too now, don't we? If I'm not mistaken, we have like an erase piece thing somewhere. Jeez, I've forgotten so much of this. Update current piece. Okay, so update current piece. I don't know what that does. What does that do? Oh, okay, I see. It does both. It does rotate and... Okay, so we set the commit to 0 and call update current piece. That'll erase the current piece. And then we update the coordinates and set it with this set to 1 to draw the current piece. So I basically did two different... Oh, no. 0, that's the tile index you want to put in there. I remember now. That was actually rather clever. So at this point, we have a valid rotation. So we load 0 and update the current piece to erase it. And now we need to take those values that we figured out and make those the current piece values. So we're going to do a little loop here. We'll call this the rotate commit loop. And in this loop, we're going to load all those values. So we got test piece X, Y, and we're going to store it at current piece X, Y. Decrement Y, if it's not negative yet, keep going. So we're taking those values, those test values, which we know are good now, and just copying them up to the actual values. And then we load 1, because that's the tile we want, jump to update current piece. Okay. JSR. So, all right, so now having performed the rotation, we need to see if we're at the end. We need to update the index for the next rotation. So what we're going to do is we're going to load the rotation index. Oh, you know something I forgot? The rotate index needs to be adjusted here. It's 8 bytes, right? So we need to multiply the rotate index by 8 to get to the correct entry in the table. So what we're going to do here, where do we load the index at? Oh, we never even loaded it. We just went straight to it. Okay. I forgot to actually check the index. No, what we're going to do is, yeah, okay, this is actually wrong. We need to use the correct index here. I just totally forgot to do that. So what we're going to do is we load the rotate index. And we need to multiply it by 8 to get to the correct table entry, because the table entries are 8 long. So you can multiply by 8 by doing 3 left shifts. And then we're going to transfer that to Y. That's going to be the index. And we're going to use X to control where we write to. So we load that. We load current piece X. We add update table Y. That's correct. Store it there. Now we need to... No, we need to do... This needs to be 0. Then we increment Y. Increment X. Okay, I think that's right. So that should work now with the index. We'll find out in a bit. All right, so the next thing we need to do is to test whether we need to loop around or not. And I think what I'm going to do, I was going to do it down here, but that would require another, well, actually, no, it wouldn't. I mean, we could do it right here. Let's do it right here. So if the rotate index is currently at the rotate end, we'll compare it to rotate end. If it doesn't equal rotate end, we'll jump to rotate index OK, which is where we're going to do all this. Otherwise, we have to set the rotate index back to 0. So we'll just 0, store it there. Actually, we're going to do a little trick. We're going to set it to -1. And the first thing we're going to do at rotate index OK is increment the rotate index. Well, hold on. No. Because we need to keep the index. The index needs to be in A. So we'll load. Well, we need to increment it and then load it, is what it comes down to. So load rotate index. Okay, so that should make it loop. And if I did this correctly, we should have a rotating piece. So let's see if this works. It's probably going to explode horribly. We'll try it. Whoa! Yeah, it's going nuts. I see a little screen skip, too, on the first rotate. Something's going crazy here. Oh, look at that. Why is it doing that? And then something doesn't... Okay, so we have clearly goofed up somewhere. All right, so let's see. We load the rotate index, compare it to the last index. If it doesn't equal the last index, we're fine. Oh, wait. This is the index we're going to. Yeah, this is all screwed up. Rotate index OK should actually be... actually, increment rotate index should come after we load. You know what, this is... I'm probably doing some wasteful instructions here, but I don't care. I'm just having trouble thinking about this right now. Okay, so... Oh, there we go. Look at that. We have a rotating piece. Now, if I move it way over here, it should fail to rotate. And it does. Oh, okay, that's not right. Oh, you know what's happening? I think it's incrementing it even when it fails. Or am I wrong here? Oh, yeah, okay. This actually has to go at the bottom. I didn't realize that. Yeah. So the rotate index is the next index to rotate. So we're going to do the rotation. And we only update the rotate index if the rotation was successful. I screwed that up. That's wrong. So okay, so this is... Okay, so down here, after we finish doing this, this is where we have to update the index. So we'll load the rotate index. Actually, we're going to load it into X. We're going to increment it to the next index. Compare it to rotate end. If it doesn't equal rotate end, we're going to branch to update rotate index. And here we're just going to write X to rotate index. If it does equal rotate end, we need to reset it to 0, so we're just going to load 0. Okay, so I think that'll work. Rotate, 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 rotate. Great. Now if we go way over here, it fails to rotate. Here, fails to rotate. Still works fine. Way over here, that's fine. Here, nope. Now if you get really low, it should fail. Yep. Look at that. Okay, so we got a rotating straight piece. All right, so now that we worked out the kinks, the other pieces should be pretty easy. So I think we're going to start... I think we're going to continue with the... I think we'll continue with the two-stage pieces, the two-step pieces. They only have 2 entries. And this took a lot longer than I expected, because I ran into some serious bugs and configuration problems and trying to figure out what the fire button was and all that stuff. So I think we may save line clearing for another session. So I guess there might be one more video coming down the pipeline at some point. But let's go ahead and do the rest of these rotation tables. So actually, you know what we're going to do next? We're going to do the square piece next, because the square piece does nothing. So what we're going to do is... this is an easy one. Square rotation is just 0, 0, 0, 0, 0, 0, 0, 0, because the square piece doesn't rotate. So now the rotate table, when we set up square low, square high. Okay, now we're going to go and force the square piece. This is an easy one to test. It's piece number 5. What did I do? Oh. Pfft. Don't know what I was doing there. What did I do now? What are you complaining about? I got rid of square low, square high. What do you... There we go. I think it hadn't fully saved before I tried to build it. It happens sometimes. Okay, so now we got the square, and rotate does nothing, just like it should. It's doing absolutely nothing. It actually is rotating it. It's just rotating it within itself. So there's no change. Nice and easy. So we're going to do the other two-step pieces. So we're working from the bottom up. So we're going to hop over. We're going to skip piece T for the moment. Well, the other I'm going to do, I'm going to put the label in here, just so I can start filling this table in. Or you know what? No, we'll do them all. We'll do T rotation now. So that's piece 4. Now this is going to be a trickier one because this has 4 steps. Okay, so what is this going to look like? Now, I remember these pieces are backwards, so we got different formats here. This was my mistake. I should have used a common piece format. It does make this a bit more difficult than it needs to be. But so we need the X values from last to first. So the T piece, as it comes in right now, is like a flat top with the one thing sticking down. So we're going to rotate, I guess, clockwise, which would be that way to you. So if we rotate clockwise, the little stub on the T piece should be pointing to the left. So the last piece in the T piece is 6-1. That is the little T stub piece. So that then, if it's going to go over to the side, it's going to go -2. And its Y value is going to be -1, I believe. So the next piece looks to be, if it's laying flat, the rightmost piece. I keep forgetting this is reversed in the camera. To me, rightmost. To you, leftmost. The rightmost piece, which is 7-0. So if we're I'm trying to visualize this. This is going to go left 1, down 1. So -1 and down 1 is going to be +1. So then we'd have the piece directly over the little stub. That's going to be our axis of rotation. So that's not going to go anywhere. And then the final piece would be the leftmost piece, which is going to go up 1, over 1. But you know, this actually could be defined in a number of different ways. I'm kind of doing the naive way, but there are different ways you can do this. But I have to do the same amount of work no matter how I do it, so it doesn't really matter. In fact, you could actually do this just by moving one piece and leaving the rest where they are. In fact, you know what? That is a simpler way. Because if you think about it, when you rotate the T piece, it's really only one piece that moves. So if we're going from the flat T to the stub facing left, we take the rightmost piece and move it up 1, over 1, and that'll do it. So the rightmost piece is the third piece. So it's going to be 0. The third piece is going to go -1, 0, 0, 0, -1, 0, 0. Okay, so I think that'll do it. Let's verify this, because we got to look at all these rotations. Since each rotation builds off the previous one, we need to look at each one to make sure we're getting them right. So here's the T piece, and look at that. So I just took that one block and moved it up, and that gets us to where we want to go. So now we want to put the little nubby on the top. So to put the little nubby on the top, we're going to take the piece on the very bottom. Oh. But you know what the problem with this, though, is you got to remember which piece is which, because now it's getting all mixed up. So this is actually a bad idea. What I was doing before is probably smarter, because otherwise it's going to get confusing real quick. So we'll do what I was doing before. So the last piece, which is the little nubby, is going to go -1, -1. The second to last piece, which is the rightmost piece, is going to go -1, +1. The third piece is the axis of rotation, which goes nowhere. And the last piece is the leftmost piece, which is going to go +1, -1, I believe. Okay. This is just easier for me to think about over the course of the 4 rotations. I mean, you could pull this off, but I would have to diagram the thing. Okay, so that's fine. So now we want to rotate around to put the little nubby piece on top. So it's easier for me to visualize this way. So now the last piece, which is the nubby, I love calling it that, is going to go 1, -1. The second to last piece, which is now on the bottom, is going to go -1, -1. The third piece is the axis of rotation, so that goes nowhere. And the fourth piece, which is now the one up top, is going to go +1, +1, I think. Yeah, I probably should have made diagrams for these ahead of time and planned all this out, but oh well. So now we rotate once, we go there, rotate again, we go there. Excellent. That's exactly what I wanted. So now we want to put the nubby on the right. The nubby. I think this is going to be the most difficult piece to do, honestly. I think if we get this one done, I think the rest will be easy. So if we want to put the nubby on the right now, so the nubby's going to go +1, +1, +1, +1. The last piece would now be on the far left. So that's going to go +1, -1. The next piece is the axis, so that goes nowhere. And the final piece is now the one on the far right, which is going to go -1, +1, if I'm not mistaken. Let's see. Magic time. There, there, there. So now we have all the positions. Now the last one's going to put it back to its original state. So we're going to go, okay, so at this point the nubby is now facing right. So we're going to want it to go -1, +1. The first piece is now the bottom piece. Or the last piece? No, it's the top piece. So it's going to go +1, +1. And third piece is the axis. 0, 0. And the fourth piece is going to go +1, +1. I think I got that right. Now we should have a complete rotation cycle, I believe. Whoa. Okay, that was a problem. Doot. Nope, I screwed up the last one. Oh, I know what I keep screwing up. I forgot about the top of the board. Because we're trying to check value. Yeah, okay. I don't know if I'm going to fix that or not. I probably should. All right, so... All right, let's look at this again, because I obviously screwed it up. What did I screw up, though? Look at it go. I'm not really sure what I screwed up there. All right, I'm probably best just starting over. So we started with the nubby pointing down. We went all the way around. So now the nubby's currently pointing right. So the nubby is the first piece that moves. It goes -1, +1. Then the next piece would be the one that's now currently on the top. So it's going to be 1, 1. And then the middle, third piece is the axis, doesn't move. The fourth piece is going to be, I believe, -1, -1. I don't know if that's what I had before or not. I probably should have kept what I had before, just as a reference, but we'll try this. Is this good? There we go. Look at that. We got a complete rotation on the T-piece. Now, there is a bug here, and you saw at the beginning, it kind of made the screen jump. If you attempt a rotation that's going to go off the top of the screen, it screws up because it tries to check that row like off the top. So I actually should probably start the T-piece in a different orientation so it doesn't do that. But you know what? For now, let's not worry about that. So next up, we have the Z piece. And this is easy. This is a two-stepper. Okay. So the Z piece, let's look at the thing here. So we still got 6061 over 5152. Okay. So I think the axis of rotation here, I think is going to be the second block. It could be either the second or the third. I mean, either one would work. I'm going to go with the second block. But remember, these are going to be backwards. So so it's 6061 5152. Okay, I got to visualize this in my head. So if we're going to rotate off the second block, I'm going to make it the third block because that will avoid the problem we're having with the T block. So if it's going to be the third block, then the last block is going to go -1, -1. The next block, which is the third one, because these are backwards, is going to be the center of rotation, so that goes nowhere. The next block is going to be -1, +1. And the last one, I think it's going to be +1, +1. I think that's right. Switch to the Z block, and we'll see if we got it right. I didn't build. Okay, here's the Z block, and rotate. Wrong button. Rotate. Okay, it's not right. It's almost right. I think I got the last block wrong. So, the last block is just going to be 0 + 1, actually, I think. All right, see how this looks. It turned into a T block. Okay, I'm obviously screwing this up. But the T blocks, it's that last block. I can't seem to, I'm having trouble visualizing what that should do. I think it should just go down 1. Oh, it needs to go down 2, not 1. That's what's wrong. Well, that doesn't seem right to me, actually. I don't think that's right. Oh, it is right. Okay, so we got that to rotate. Now, going back for a two-step block, going back is easy. You just negate everything. So this would be positive, 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 negative, negative. Whoops. What did I do there? All right, that should be a 1. Oh, of course it should be a 1. Wait a minute, I deleted the wrong character. All right. So if we got this, we should have this block fine. No problem. Except that doesn't look quite right. I guess that works. I don't know. I think that's a weird center of rotation, but it kind of works. Okay, so yeah, there are definitely some flaws with this Tetris game, I think, but it's serving its purpose. So S rotation is going to be very similar. So we'll use the same axis of rotation here. Once again, I got to visualize this in my head here. So, okay, so if 5-1, okay, so if the last block then is the center of rotation. I'm going to make a little picture here. So what we're looking at is this. One is where there's a block. So it looks like this. And what I want to go to then would be I want to make sure I keep these lined up right. So, wait, if I use the very bottom one as the center of rotation, there'd be nothing on that row. I'm just going to put in zeros right here so we can visualize it. So if that's the center of rotation, that doesn't move. But that one would come up beside it, and then these other two would end up down here. So let's see here. So the last block is the one on the bottom. So that's going to go -1, -1. The next block, I've screwed up my picture. All right, the next block is the axis, so that's not going to change. Then we've got, let's see, that block then is going to go -1, minus. I keep hitting keys that I expect to go places. They're not going because I have these comments in the way. -1, +1. And then the last one's going to be 0, +2, I think. Okay, so let's see if the S block comes out okay. Rotate. Hey, perfect. Got it on the first try. I think that picture helped. But I'm going to get rid of it now because it's all screwed up and it's annoying me. So once again, with a two-step rotation, all you need to do is negate all the values, and you get to go back. So get rid of the minus, get rid of the minus, get rid of the minus, minus, minus. So now we should have a working S rotation. Excellent. And now we need to do the L blocks. So these are the last two. So let's see here. So I think reverse L comes first. Okay, so this is another one of those four-steppers, so it's a little complicated. Now, I think I'm going to use the bend in the L as the axis of rotation. So it looks like it's 1, 2, 3, over. So the third is going to be the axis of rotation. So L reverse looks like that. So if we rotated it, the very last piece is going to go +1, -1. The next piece isn't going to move because that's the axis. Then we have the piece right above the axis, which is going to go +1, +1. And I believe the other piece is going to go +2, +2. Now, I think there's going to be a bit of a pattern to this one. I'm not really sure. Now we got to switch to piece 1. So let's see if this first rotation makes sense, and then we'll build off of that one. And rotate. Okay, great. Wait a minute. Yeah, that's fine. I may be choosing bad axes for the rotation, but you know what? I really don't. I don't really care all that much. Yeah, these are probably awkward axes now that I think about it. This might be a weird Tetris game to play, but you know what? It's not meant to be a finished game. It's just meant to be a demonstration. So we'll push forward. All right, so the next step then would be another, so the last piece is the little hook on the L. So that's going to be +1, +1 this time. And then the next piece is the axis of rotation again. So that's going to be a 0. Then, let's see, 1, 2, 3. It's going to be -1, +1, I believe. And then -2, +2. Yeah, I think the magnitude of each move is going to be the same for every rotation. It's just a question of the sign on it. So there's that. There's that. In fact, I think the rotation for the L piece might be very closely related to this one. I might be able to just copy and paste and make a couple small changes. Okay, so in fact, the stem is going to be the only thing that's going to be different is the little hook off the end. So this might give us most of the last piece while we're at it, which will be convenient. So now we went from L this way to facing down. So now to go to the next one, the last piece is going to go minus. Wait a minute. Here to here. We did that. Here. Now it's on the right. So now it needs to go to the bottom. So it's going to be -1, +1. And then they have the axis. Then it's going to be -1, -1 will be the next piece. The last one will be -2, -2, I think. I'm getting better at seeing this stuff in my head. I hope you are too. Here we go then. Rotate, rotate, rotate. Okay. God, it's ugly, but it's rotating. I didn't like that. Sounds like seemed wrong about that. I feel like that axis was off somehow. No, it's right. I don't like the way that looks, but I don't really feel. I mean, you can play around with these rotation schemes and try to get stuff that looks and feels better. But I'm mostly interested in just getting this working. So, okay, so for the final rotation step, then we're going to go -1, -1, I believe. It's going to be the first piece. That's the axis. And then it's going to be +1, -1. I think it's going to be +2, -2 is going to be the last one. All right, see if I'm right. Okay, rotate, 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 rotate. Look at that. Yeah, that's probably not a good axis to use for the rotation. You could probably do it better than that, but if you want to, hey, take the code and do it. It's an exercise for the reader, as my college textbooks like to say. So all we have left now is the L piece, which is going to be almost the same as this. In fact, we can actually copy and paste the L reverse table and use it as a foundation for the L piece, because the only thing that's going to be different is the piece that sticks up off the end, the little hook piece. The rest of it's going to be exactly the same. So if we take these 4 lines, paste them here. So we just need to change the first entry. So in fact, there's probably a pattern to this. So originally with the reverse L, it went over 1, up 1. Here it would go over 1, it would go -1. It might just be the opposite. All right, we're going to try this. We're going to just negate all of the movements of the little L hook and see if that actually ends up being right. I don't know if it will be, but we're going to try it. Oh, wait. I didn't get them all, did I? I missed one. Okay. So if we just negate the movement... Oh, wait, I got to do the piece here. If we just negate the movement of the little hook on the end. Look at that. Okay, and with that, we got a full set of rotating pieces. Maybe not the best rotation scheme, but it is a rotation scheme and it appears to work. So now we can actually do things. So let's see what we can do here. Now we don't have line clearing yet, but we can actually, kind of play Tetris here. We'll drop some stuff. I can fit that right there. Could make a line right there, but hey, we're going to get fancy. We're going to go for the big one. Ooh, where do I put that? Put that there. That looks nice right there. Look at that. Oh, yeah. Okay, here we go. 3 lines. Boom. Of course, we don't have line clearing yet. But we can rotate pieces. We got collision detection. It is looking pretty sweet, if you ask me. So we have a mostly functioning Tetris game on a very basic level. All right. This is pretty cool. This almost makes me want to actually do Tetris for the 5200. Someone else has already done it, I'm sure. Oh, make a gap. Left a gap. Okay, well, I think that's probably good enough for now. That's where we're going to cut it off. I was hoping to get through the line stuff too today, but this took a lot longer than I expected. So I guess there'll be one more session of this sometime next year. And that'll probably be the last one. I'll do the line detection and all that stuff, and that's probably where I'll end this. I don't really feel like getting much fancier with it. You could add stuff like the next piece display and keeping score and doing and level progression and all that stuff. But I'm not going to get into that. We'll do the line clearing, and I think that's where we're going to stop. But it's been a fun ride, and that'll probably be my last video in this series because I just don't think there's much more I can really get into without getting too fancy. But so we'll go ahead and we'll close it up for now. I'll try to have the final episode in, I don't know, a week or two. It depends on how things go over the new year. But we'll squeeze one more in there. And then once it's done, hopefully you've learned enough to start making some of your own Atari games. And of course, a lot of this applies to the Atari 800 computers as well, or 400, the Atari 8-bit line of computers. There are some changes, some things need to move around. Controllers are handled very differently, but there's lots of documentation on that stuff, so you can find stuff on it somewhere. But for now, we're going to be saying goodbye, and we'll see you in a couple weeks with the final installment of this series.